So in this video, I'm going to show you how to visualize a dependent samples t-test. And so again, a dependent samples t-test is where you're getting multiple, or one is getting multiple observations from the same unit. So that would be test scores from the same students or schools or something like that, but you're getting repeated measurements from the same group. And so in another video, I show you how to actually conduct a dependent samples t-test, but now I'm going to show you how to visualize a dependent samples t-test. And so to start off, I'm going to, one way to show this is by just showing the distribution of the two variables that you're working with. So in this particular data set, and so this is all public schools in New Jersey in the 2018-19 school year. And so that's my data set. So this is school level data. And let's say for the research question, I want to look at whether math achievement, average math achievement on the ACT is similar to average math achievement on the SAT. And so this would only, for this analysis, it would only be using schools where students take both tests. And so in schools where students take both the SAT and the ACT, is their math achievement and their on the SAT and the ACT different? So one way to do that would be just by looking at the distributions. So I've got two variables in my data set, math standardized, math SAT, and math ACT. And so I standardize them so that they're on the same scale. Because if you were to use just regular math SAT and regular math ACT, the raw scores that is, you would see a huge difference because the ACT has a maximum value of 36, whereas on the SAT, the minimum value is 400, so much higher than, actually might be 200 anyway, is much higher than the maximum value. So you need to put everything on the same scale. So to do that, we'll say we want to just look at the distributions for both of these variables. So one way to do that is to create a graph using the two-way command. And so what the two-way command does is it lets you layer graphs. Like you can layer data over top of one another on graphs. So let's say we want to do the let's say we just want to make a density plot for math SAT. You just need to make sure you've got the brackets. And then we'll do the same thing for math ACT. And then hit enter. And so then here is graph of the two distributions. This tells you a little bit about the shape of each distribution and so forth, but it's not incredibly helpful, right? Because oftentimes the differences that you're seeing are actually rather small. And so what you might want to do is you might want to just plot the confidence intervals for both of these variables and see if those confidence intervals overlap, which is generally going to tell you whether the difference between them is significant or not. And so to do that, what we can use is a command called ciplot. Unfortunately, the command ciplot is not native to Stata, so you just have to install it. Fortunately, it's very easy to do that. So what you would just want to do is type this command, ssc install ciplot. And so what that does is it tells Stata to look up in the online repository of commands, look up this command ciplot and download it. You only have to do this once. And so as you'll see, since I already have this installed, it's not going to do anything. So if you already have the ciplot command installed on your computer, then you don't have to re-download it, but you just want to make sure it's there. And then all you have to do is type in ciplot, and then you can just put these two variables here. These are the two variables that we're looking at. So I just hit enter. And then you'll see what it comes up with is the default for so not default, it will come up with it'll show the mean represented by a red triangle here for one variable and a green circle for the other variable. So it shows the means, and then it shows the standard error around those means. And then over here on the y-axis, it will automatically use the scale that's there. So since this is standardized, so this is z-scores or standardized scores. And you'll see here it says standardized values of school, average, math, SAT. So this shows SAT. And then this shows ACT. You could use the graph editor to make this a little bit cleaner and nicer looking and more, a little bit more interpretable. And so if you were going to put this into a report or something, you would definitely want to clean this up. But what this shows you is the mean and confidence interval for math achievement on the SAT and the mean and confidence interval for math achievement on the ACT. And this is, again, only in schools where students take both. And you can see because the confidence intervals don't overlap, that you would conclude that there is a statistically significant difference between them. You could get more precision about that difference by running the Ttest command, but this is a good way to visualize that difference.